Good afternoon, everyone. This episode is going to be about transaction comprehension. So what we're basically going to be doing is accessing properties of transactions through our contract and returning those values. So there are three different types of transactions. You have TXN, ITXN, and GTXN. And respectively, these refer to transactions, intertransactions, and group transactions. And I have an example here that we're going to look at while we discuss this. Um, so transaction refers to the current application call, the current transaction we're submitting to the contract that triggers a method and runs a bunch of code in the contract. So these would be app calls. So you see we have two app calls here. And intertransaction refers to a transaction submitted from the contract triggered by the app call. So here you'll see we call the contract, we call a method in the contract, and then it opts into an asset. And you can see here it's labeled as inner in this visual here. So app call is transaction, inner transaction is a transaction submitted by the contract triggered by the app call. So a group transaction refers to the entire group, but specifically only outer transactions. So you see I have a payment transaction to the application, I have an app call, I have another app call, I have an asset transfer, and I have another payment. And these are all group transactions. And it's also a bit about perspective. So when you're accessing the current transaction, it refers to the current application call. When you're referring to a group transaction, it refers to any transaction in the current group. The application call is the only one that can be referenced as a transaction. And this might sound like word salad right now, but it'll become more apparent as we actually write the code and go through it line by line and actually write it out. So we're going to go into our new folder, which I just named it AlgoLearn, TXN, ITXN, GTXN. You can name it whatever you want. And the first thing I want to actually go over is a small issue some people have been having with the .env files. So you see here I created a .env, and I have private key equals 123. And usually what you'll see me do, will create test.py here. You'll see me import OS, and then I'll use something like private key is equal to os.getEnv private key. So the private key variable is going to be equal to, go to the .env and get the key, the value to the key called private key. Okay, and then it should return 123, and when we print private key, we should get 123 as a string. So what's happening for some people is when they print private key, they get an empty string. And if this is happening to you, and I'm going to add some disclaimers on the website per video, for the videos that I didn't use this method, and from now on I will use it, what you need to do is install, if this is happening to you, pip install python -.env. And this you would put into your terminal and press enter, and it would install the python-.env library. And then instead of only doing this, you would just add one more line of code. Well, two more. You would import .env, and you would get the .env load.env function, and then you would just call load.env. And I guess in my environment, the Visual Studio Code just knows I have a .env, recognizes it when I call os.getEnv, and I don't need to import these two. But the best practice is to load .env so that even if Visual Studio Code doesn't recognize it, this load.env will look for the .env and actually grab the current state of the .n for you to use in your code. So from now on, we're going to be using this. You don't have to. I wasn't, but just for people who don't have their .env being recognized without it, we're going to start using it from now on. And again, I'm going to add disclaimers for anyone who had this issue in the past, and I apologize that you were not able to get these .envs to work. So the first thing we want to do, and we don't need this test.py, we're going to generate an account. So we have a real private key. So generate account.py, and we've done this several times. From algo SDK.account, import generate account, private key address is equal to generate account, and then print private key and address. And this is code we can just copy and paste, but I'm just writing it out here. And what we do is we take the private key and we put it into our .env, like so. And then we take the address, we don't need to save it, but we go to bank.testnet.algoLearn.network, and we've done this several times before, and we just fund the account with 10 algo. And then we don't need generate account anymore. And then we're going to import our launch smart contract.py. So just create launch smart contract.py and copy and paste the previous code that we've been using to launch the smart contract. And of course, you're going to need the algot token, which is going to be empty, and the algot server, which we can get from nodely.io. Nodely.io, quick start, and second row, testnet, second column, full algot v2 API. We're going to copy this testnet public API so we can submit transactions. And then in our launch smart contract, see I have the load.env already. We're going to only need to change, as always, the approval and clear teal file names, because when we write new contracts, the names of the contracts are different depending on what we're working on. So I already changed mine to transaction comp. Yours might be Archer from the previous video. And then also in the global and local state schemas, we're going to have these set to 0 because we're not going to be using global or local states. And then everything else can stay the same. Now we're going to actually write the smart contract, and I'm just going to quickly close Visual Studio and reopen it because I'm having this white text, which is confusing to me. So give me 1 second. All right, I'm back. So we're going to start writing our contract. I'm going to call it transaction comprehension.py. And as always, from algopy, import arc4 contract. And from algopy.arc4, import ABI method. We're going to define our class, and we're going to call it transaction comp. And the name of your class always has to match here in your launch smart contract if you ever get an error. Make sure that this matches the name of your contract, because when you generate your approval and clear.teal, the name of the teal file will be based off of what you name your contract here. So transaction comp, pass in arc4 contract, and then here in our initialization, we don't have any type annotation, return none. We don't have any global or local states or structs, which we go over in videos later on. So we can just pass. And then for our first ABI method, use a decorator, we're going to say def transaction comprehension, pass in self, and return none for now. But we're going to return a myriad of things later. So how do we access properties of the current transaction, the transaction that is submitting this application call? We do this by importing capital TXN from AlgoPy. And if we look at TXN dots, we can see all the properties we can access about the current application call. And there are some things that I think are arbitrary and shouldn't be here, like amounts, which is an amount of algo that's transferred, or asset amount. And that's because I don't think you can transfer assets or algo in an application call. I could be wrong, but I've never done it this way, aside from including arguments with transactions. But there are things that we do think will be important. So application ID is important. There's other things here like application args, which is right here. And application args refers to the arguments. So for example, if I had asset ID here, and it's going to be an asset, which I would need to import. And this is just an example. We're not going to actually type this in later. So if I wanted to access the asset ID variable as an application arg, I would use transaction.applicationArgs1. And when we learned about list comprehension, because this returns, this accepts a UN64, which is the index of the application arg. So if I want to get the first argument, I would use 0. But asset ID is the second argument, which is 1. And that's from list comprehension. And you might be thinking, there's no other arguments here. Wouldn't asset ID be 0? And that's false. The first argument is always going to be the bytes version of the method selector, or the name of the method. And I'm going to show you that later. It's going to be 4 bytes. And another thing we can access here, we have applications. And application refers to foreign applications. So this would be applications or app IDs that are not the current application. And similar to foreign assets or arguments, application arguments, the first one is always the current application. And similarly for accounts, the first one will always be your account. So the reason we have accounts and applications is because we need sometimes to reference accounts that are not our own and their state in this contract. For example, the local state of another account. By default, our account is already included in the accounts array. But if you wanted to manually include a second account, you would need to reference that in your foreign accounts array. Same thing with foreign applications, which is indicated by applications here. And we'll see an example of this later. But you basically need to give a ticket to the contract to say, hey, by the way, here's an asset, or here's an account, or here's an application that you don't know about currently through me. So I want to pass you this ticket so you can get that information and come back to me with it. If you didn't include these foreign arguments, it wouldn't have access to that information. And this is more of an advanced concept, but we actually do get into foreign assets later. There's other things we can access, so we can get the fee, and we can get the transaction ID, tax ID, and we can also get, let me think here. Oh, that's pretty much it. That's the most important information anyways. So what we're going to do is try to access as much information as possible. So what we're going to do here is we're going to put in sender, so the sender of the current application call. We're going to get the foreign accounts, and we're going to get the one in the second position, or the first index. And we're going to get the application arg, just the first one. So transaction application args at the first index, or first position, the 0th index, first position. And we're also going to get foreign applications. And I'm going to show you the 0th index, the first position, which is going to be the current application. We're going to get the foreign asset, and this is going to be the first foreign asset included. By default, this is empty. So the first one will always be one that you include. There is no default asset that's included. And we're going to actually get information from this foreign asset. So we're going to get the name of the asset. We're going to get the unit name. And let's also get the balance that we have of this asset. So we're going to get the balance, and we're going to pass in our own account. So the sender of this transaction, get the balance of this asset. And then we can also do the creator of that asset. So foreign asset one dot creator. And then we can also get the fee for this transaction, which is transaction.fee. And we can also get the transaction ID. And then we're going to return these one by one. And we're also going to get the transaction type, which is transaction.transaction. Should be type. Oh, there you go. And now we're going to return all of these. And this isn't going to work. So if you don't want to write all of this down, you don't have to. But I want to show you why it doesn't work so that you can understand what we have to do here. Oh. Just going to type all this out. One moment. Just going line by line. And this is looking a little bit ridiculous, but this is what learning is. Okay. And for us to return all these things, we need to pass in the return types up here. So we're returning the sender, and this is going to be a tuple of several things. So we're returning the sender, which is an accounts, and we need to pass an account here from AlgoPy. So we have an accounts, we have foreign accounts, which is going to be another account. We have app arg1, and if we hover over this, it's going to be bytes, and it states here it returns bytes as well. So we need bytes. We're going to grab that up here. And after app arg1, we have application. So we're going to pass that in here and import. And again, you don't have to write any of this down because we're going to have to fix it. Next up, we're going to need, so application asset is next. After that, it's going to be bytes and bytes again. And then after that, we're going to get a uint64. And we need to pass this in here. And then after the balance, we have the creator address, which is going to be another count. Fee for this transaction is going to be a uint64. Transaction type is going to be bytes. And then transaction ID is also going to be bytes. And we're going to try to compile this. And see all the errors that we're going to get. And these errors are due to return value types are incompatible. So there are only certain kinds of classes that you can return in an ABI method. And most of these are not supported. So instead of account, we need to use, from arc4, we need to use address. Okay, so this needs to be address, and this needs to be address. And over here, this needs to be address. And we have accounts here, so what we need to do is manually convert them to addresses. An address takes as a value an account. So we're converting the account to an address. We do the same thing here for the second return. And then we have another one down here, which is going to be the creator address. Here, creator, which is an account. Now, if we try to compile, we're still going to be missing some things. So the next thing that we need to adjust is a uint64. And the uint64 that we're using currently is not supported for a return type. So what we need to do is use, and I don't believe we're going to need uint64 from AlgoPy at all. What I usually do, actually I'll leave this here. What I usually do from algopy.arc4 import uint64 as arc4 uint64. And this is a special type of uint64 that allows you to return uint64s from methods. So what we're going to do is wherever we see an instance of uint64, we're going to use this one instead. Okay. And because we have arc4 uint64 here, we have to convert the uint64s we already have, which is going to be balance and fee for this transaction, into arc4 uint64s. So we're going to go to balance. We're going to say arc4 uint64 instance of the balance value we're getting now, which is a uint64. And the same thing here for the transaction fee, convert this into an arc4 uint64. And when we compile, we're still going to get errors. Let's see here. So next up, it's going to be asset. So we cannot return asset. So this also needs to be an arc4 uint64. And we're going to go over to where we get the asset, which is here. And we're going to convert this to an arc4 uint64. And what we're actually going to do is we're going to return the ID, because that's essentially what asset is. So for an asset, one.id. And this returns a uint64. So we need to convert it to an arc4 uint64. And let's compile. Let's see if we got it right so far. Nope. So what else are we missing here? Application. So application also needs to be converted into an app ID. So transaction for an application ID is equal to transaction for an application's dot ID. And this returns a uint64. So we need to convert it to an arc4 uint64. I'm going to save, try to compile. And we need to change this, of course, to a uint64 where it said application. And I think we should be good. Nope. Yes. So instead of returning transaction for an applications, we're going to return, and I did not realize I spelled that so horribly wrong. So we're going to return that instead. And for foreign asset 1, we're now returning foreign asset ID instead. And that's going to be we weren't even passing that in. So that's going to be right before asset name. So we should be good now. Perfect. So for returning values from ABI methods, they all need to be supported arc4 types for ABI methods. So this looks horrible, but it's all we need for transaction comprehension. So what we're going to do is create a interact with contract.py. And we're going to set up an application client. I'm just going to copy and paste since we've done this a few times before. And the only thing we need to change here in your application client file, make sure you change the name of the JSON so that it matches this here. Your transaction comp arc32.json. Other than that, we can start writing our code here. So we want to interact with this method, transaction comprehension. So we're going to go to interact with contract, and we're going to compose a call, and we're going to pass in our atomic transaction client, call the ABI method, input the name of the method as a string. It doesn't need any arguments, but over here, for foreign accounts, we are going to pass a completely random account. So I'm just going to generate a random account. And we just need the address here. And over here, in interact with contract, we're going to say arbitrary account is equal to, and a string with the address. And to pass in foreign accounts or foreign assets or foreign applications, we're going to need to include them in transaction parameters, which is going to be a dictionary, and accounts is going to be the key we want to manipulate or add and modify. And accounts needs to be a list, and we're going to include our arbitrary account. By default, our account is at position 0. Our contract gets the account at position 1. So this, although it's a list with only one account, and this is the 0th position, or the first position, 0th index, it will still pull our account first. So our address will always be first, even though it's not in here. And then also in our contract, we try to access the asset in the foreign assets array. And currently we don't have an asset. So I'm going to create a test asset from Algo SDK, transaction, import, asset create transaction. And then we're also going to need our Algo client. And we're going to need import OS. We're going to get our keys for our server and token. And we're going to create an asset here. And we're going to need our private key. And our address is going to be from Algo SDK.account, import address from private key. pass in our private key. So sender is going to be our address. SP, suggested params. AlgoClient is where we get this from. So params is equal to AlgoClient, suggested params. Next up, it wants the total. Let's create 10. Decimal 0, so it can never be a fraction of itself. Default frozen, false. Manager is going to be us. Reserve is going to be us. Oh. And I think asset name, we'll say test asset 1. And then unit name we can put as test number 1. And that should be it. We're going to sign. So signed asset create transaction is equal to asset create transaction dot sign. Pass in our private key. And then the transaction ID is going to be equal to the result of sending the transaction, an attribute of the Algot client. And we pass in the signed asset creation transaction. And let's print the transaction ID. And what I want to do is I want to wait for confirmation and pass in our client and transaction ID. Wait for confirmation is something we have to pass in from transaction library. Wait for confirmation. And what this allows us to do is get the transaction info after it's completed using pending transaction info. We're going to pass in the transaction ID from the asset creation transaction and print transaction info. And if we send this now, we're going to get our asset and the asset ID from the asset info. And we're going to use this to pass in to some of our transaction parameters. We're going to get a key called foreign assets, and that's going to be equal to a list with our new asset ID in it. And for future use, I'll put asset ID is equal to asset ID we just got. And instead of passing in the number, we'll just put asset ID in here. And that's pretty much it for transaction parameters, I believe. So let's try calling this. We're going to say atc.execute, and we're going to pass in our Algot client, and we're going to wait 2 rounds. And results is actually equal to atc.execute. And what we're going to do is get the transaction IDs from the result. So results.abi results.transaction IDs. Oh, ABI results 0.transaction ID. And then the ABI results, or the return results, return values maybe, is equal to results.ABI results 0 dots return value. And we're going to print the transaction ID and print the return values. And let's run this code and see what we get. Hopefully not an error. FID, we need to launch our smart contract first. So we're going back to our launch smart contract.py and make sure your approval and clear teal file names match. And we get our FID here. We're going to put it in our .env. And we're going to try interacting a second time. And we get our transaction ID here. And we get this mess of a return value. And let's look through this one by one. We returned a lot of stuff here. Okay. So going back to our contract, the first value that we returned is our address. The second value we return is the arbitrary account, which is the account at the first index or the second position. And as I mentioned, by default, our account is at the first position or the 0th index. The next thing we return is apparg1. And apparg1 is always the 4 bytes representing the method we're calling. And we can confirm this is correct by using method from the ABI library. And if we go to our arg32.json, we get the name of our method. And this contains all the values it returns as well as the arguments. We have no arguments, but we do return several things. So if we copy and paste this string and attempt to get the method bytes for the selector, we can do here selector bytes is equal to method.from signature, pass in our signature, get selector, and print selector bytes. And the format we have our selector bytes is not actually in bytes, it's a list of integers. So what we can do here is convert these bytes to a list of integers like so. And you'll see that they match. So what we did is we basically converted our method name with its arguments and return types into bytes, and then a list of integers, and it matches the 4 bytes or 4 integers that we get returned from appargs, the 0th position, 0th index, first position. And next up, I believe this is the app ID. So this is the same as our current app ID. And that's because by default, the foreign account, the foreign applications array has our application at index 0 or position 1. And next up, we return the foreign asset ID. And we'll see here that our asset 1, our asset ID matches the asset ID returned, which is 0th index of the foreign assets array. And this is going to be, I believe, after asset ID, we return the asset name. And the asset name as bytes is kind of hard to kind of decode. What we can do is we can import string from the arg4 library, and for the asset name and the asset unit name, instead of returning bytes, we can convert those bytes that we get from the name and unit name properties as strings. So wherever it says bytes here, right here, I'm going to change that to string. So what we need to do is use string from the AlgoPy library. Because the arg4 string, what it does is it pads a prefix to the string that indicates how long the string is. So if I had a string that was like hello, what an arg4 string looks like is 5 hello, because it lets you know how long the string is. Our asset name and asset unit name Our asset is called test asset 1. It doesn't have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It doesn't say 14 test asset 1. So when we try to decode it using arg4 strings, it won't work. Let's compile again. And then launch. And then we place our new app ID in our .env. Interact again. And you'll see our asset name and asset unit name should now be present here. Perfect. So we see here test asset 1 and test number 1. So we can just replace this here. So now it says test asset 1 and test number 1 instead of bytes. And then after this, we have 10. So asset balance, this is how many of the asset we hold, which is 10. When we created the asset, we created 10. Next up, we have this address, which is the creator address of the asset, which is us. After that, we have 1,000, and that's the transaction fee. Transaction type, it's 4 bytes. And I'll quickly show you here how to confirm. What we can do instead is, for transaction type, we can do the same thing we did with the asset name and unit name, and replace the second to last one here, bytes, to string. And we'll get the type for the transaction, which this will be APPL, which is short for application. See? And lastly, we have this long string, and this represents a transaction ID as bytes. And something kind of niche about this, a AlgoLearn address, which we see here, passes back fine, even though it says bytes when we use address. So we don't get all these 32 bytes when we return an address. We're returning bytes for the transaction ID, but the quirk here is that addresses and transaction IDs are both base 32 encoded. So if you use address here, you'll actually get the transaction ID, even though it's not an address. And that's something I think maybe they should update, even though it's we have to change this to an address type. They should add a transaction type that you would pass back here. But for now, until they update that, you can use address. And we'll launch here, pass in the app ID. And interact with our contract one last time. And that is pretty much transaction comprehension. So we get the transaction ID here.